Hello, welcome to 5.1 day 2. Today we're going to work on examples 5 through 7. Example 5 asks us to simplify a trig function expression. At any time, if you feel like the video is moving too fast for you or can't keep up with your notes, just press pause, write it down, and press play to keep listening to the explanation and go at your own pace. Here in example 5, our job is to simplify the sine of x plus the cotangent of x times the cosine of x. So what I want to do is have my formula reference sheet in front of me. I'm going to look at it, and that'll help me determine which ones I want to actually use. Okay. Well, first thing I notice about this one is that the cotangent of x is the same thing as cosine of x over sine of x, and so all I do is replace it. And that helps me when I do some multiplication there. I'll get cosine squared of x over sine of x. Sorry, that's plus, not multiplication. Next thing I'm going to notice is that I'm going to try to add these two fractions together. Well, sine of x is over 1, so sine of x over 1 we add it to sine of x. I need to multiply it times sine of x over sine of x, and over here on the right of my squiggly is my workspace. So to do that, that would give me sine squared x over sine of x. And so now when I add the two together, this fraction takes the place of that one right there. And so when I add the two together, I got sine squared x plus cosine squared x. Denominator stays the same, which is sine x. My Pythagorean identity states that the sine squared plus cosine squared of x is equal to 1. So I'm going to replace that with 1 over sine x, because the Pythagorean identity says that this right here is equal to 1. And 1 over sine x is equal to the cosecant of x. And there we just simplified that trig expression. Okay? What I'd like for you to do now is try number 61. Number 61 says that the tangent of x minus secant squared of x over tangent of x, and I want you to simplify that. What I noticed is that, well, first of all, press pause, see if you can figure it out before you listen to the explanation of the problem. Okay? Now we're back. First thing I'm going to do is, just like we did on the one before, is come up with a common denominator of tangent of x. So it makes this tangent squared x over tangent of x minus secant squared x over tangent of x. And when I put it together, tangent squared x minus secant squared x over tangent of x. Well, there is a Pythagorean identity that has secant squared and tangent squared in it. And that identity states here in red that 1 plus tangent squared of x is equal to the secant squared of x. Now, how does that help us out, or does it help us out at all, is the question. Well, what I notice is that this says tangent squared minus secant squared, so if I subtract the secant squared x from both sides, I get 1 plus tangent squared x minus secant squared x equals 0. And if I subtract 1 from both sides, that'll give me tangent squared x minus secant squared x equal to negative 1. And since I have tangent squared x minus secant squared x right there, I replace that with negative 1 over tangent of x. Tangent of x, 1 over tangent of x is cotangent x, and so the answer to number 61 is negative cotangent of x. Okay? For our next example, we're going to go into example number 6. And example 6 says that 1 over 1 plus sine of x, and it wants us to write this without a fraction. How am I going to write this without a fraction? That is the question. See if I can put that all on the screen for us. That hopefully clears up any screen issues we just had, if we had any. Well, first thing I notice is I have a fraction. First step is to multiply top and bottom by 1 minus sine of x. That way, we can get that subtract, the adding thing out of the bottom, just make it one trig function. And so I do the multiplication, I get 1 minus sine of x, and by doing 1 times 1 I get 1, sine of x times 1 and 1 times negative sine of x, those two are going to cancel out, and I'll just have minus sine x squared on the bottom. Okay? What I noticed about this next is I have my Pythagorean identity over here on the right, sine squared plus cosine squared equals 1. If I subtract sine squared from both sides, I get cosine squared of x equals 1 minus sine squared of x, right off your trig function sheet. And so I can replace this 1 minus sine squared of x on the bottom with a cosine squared of x. So I have 1 minus sine of x over cosine squared of x, like that. For this one, probably the easiest thing to do is I know that 1 over cosine is something and sine over cosine is something. So I'm going to change this and I'm going to break it apart into two fractions. Now I know, just like before, if 1 over cosine is secant, 1 over cosine squared is secant squared of x. What to do with sine over cosine squared of x? Well, what I know is that if I break it down into sine over cosine times 1 over cosine, and I can do that because if I do the reverse multiplication of these two things, it comes up with sine over cosine. So I can do that. And so rewrite the secant squared of x. Sine over cosine is the same as tangent of x. 1 over cosine is the same as the secant of x. So this, to get rid of all the fractions, becomes secant squared x minus tangent x secant x. Okay? Well, why don't we go ahead and try number 65, the same type of problem here. I'm not sure why this keeps moving off my screen, but it does. See if we can't adjust it a little bit. It doesn't want to adjust this time, so let's just go with it. Try number 65. Press pause if you need to. We come back and try to figure it out. Again, start this one with 1 plus cosine y over 1 plus cosine y and multiply. However, this one's a little bit different. I'm not going to do distributive property this time because if you notice what happens, on the bottom I'm left with 1 minus cosine squared of y. And coming back to the idea of my Pythagorean identity, sine squared plus cosine squared equals 1. If I subtract the sine squared, if I subtract the cosine squared, I'm left with sine squared equals 1 minus cosine squared of y, or x, or whatever letter you're talking about, doesn't matter. Well, that means I can replace 1 minus cosine squared with sine squared. So I have sine squared of y times 1 plus the cosine of y over the sine squared of y. Sine squared of y's cancel. Final answer, 1 plus the cosine of y. So it was similar, the strategy changed a little bit. How am I going to know if I should just do distributive property here or not? Well, trial and error. Trial and error. Fun, I know.